Audible? Hi guys, welcome to Smart Coach. So in your yesterday's live class, we have completed about the plate tectonics theory, right? So your plate tectonics theory was divided into two sections. In the first class, we talked about the different theories which culminated and resulted in the plate tectonics theory as a whole, right? So there we talked about your two different important models. The first one we talked about was your mantle convection cell, and secondly we talked about your sea floor spreading theory, right? Then in the next class, we went on to talk about the theory in itself, where we understood what are your different types of plate boundary interactions and what were those. Those were your divergent boundary or constructive boundaries. Then we had uh, your convergent boundaries, and then finally we talked about your transform boundaries, right? So depending upon the different types of boundaries, we get different types of features which we have dealt with. Now moving on from your plate tectonics theory, today we will begin with a new topic, which is your earthquakes. And this lesson of earthquakes will be divided into two sections, part 1 and part 2. And in the part 1, it will be very theoretical and factual in nature. There we do not have to understand much of concept. So I will be dividing this earthquake into two classes. So in the first class, we will go through a brief introduction about what is an earthquake, what are the different types of earthquake. Then we will understand the different reasons behind the earthquakes as well as the distribution of earthquakes. And then we will finally conclude the class by talking about the different zones that are found in India. Fine. Now India is divided into four zones, zone 2 to zone 5. So we will talk about this in which states fall under which zone. All right. So let's begin today's class. So first class, we will just begin with a brief introduction. All right. Okay, fine. Let's begin. So this is your lesson number 11 of your module 1. Your module 1 is your geomorphology, right? So we will begin this class by giving a brief introduction. Then we will talk about the different causes of the earthquakes. Then we will talk about your different types of earthquakes. Then we will talk about the earthquake distribution in the world and India. And then we will also talk about how we measure earthquake, right? Now there are two important scales. One is called as a Richter scale, another one is called as a Mercalli scale, which we are going to talk about. Fine. So let's begin. So what is the first point? An earthquake is shaking or trembling of the earth's surface, which is caused by your seismic waves or earthquake waves. Now these seismic waves that you see here are of different types. Now there are something called as your surface waves. Then there are something which are called as your body waves. Now, what are these surface waves and body waves? We will talk about this in tomorrow's class because this is a very extensive topic. Now, earthquakes, for example, the body waves and the surface waves are again of different types. The way they propagate throughout the interiors of the earth is also very, very complex, right? So this will take 1 hour at least for you to understand. Therefore, I had to divide this topic of earthquakes into two different classes. All right. So we will talk about this in tomorrow's class, right? So next point, these waves are generated. What waves? These seismic waves are generated due to sudden movement or because of a sudden release in the earth's crust or in your upper mantle. So where is your earthquake originating? Your earthquake is nothing but your release of energy. And where is this energy releasing? It is either releasing in your crustal region or it is releasing in your mantle region, right? And the earthquakes which are originating in your crust region, they are called as a shallow focus earthquakes. Now we will understand what is shallow focus earthquakes are, but for the timing, just understand that the earthquakes which are originating in the earth's crust, they are called as your shallow focus, and the ones which are occurring in your upper mantle region, they are either called as your intermediate earthquake or they are called as your deep focus earthquakes. All right, fine. Then a seismograph or a seismometer is the instrument which is used to detect and record your seismic waves or the earthquake waves. All right, so this was about the introduction. Now while we deal with the topic of earthquakes, we have to understand certain terminologies, and the first terminology is the focus. Now what is this focus? Focus is the point where the energy is released. All right, and this energy release will take place where? It will take place below the earth's surface, right? Now suppose this is the earth right? Below the earth's surface, there will be a point, and this point, what will happen in this point, energy will get released. Understood? Once this energy is getting released, it will reach the surface of the earth in the form of seismic waves. Fine. So at the point where the energy is released, these are called as your focus areas. Understood this? Right? And this focus has another term which is called as a hypocenter. So your focus and hypocenter is the same thing. Understood, focus? Now if we have understood what is a focus, we have to also understand what is an epicenter. Okay, let's go on to define what an epicenter is. The point on the surface which is directly above the focus is called as the epicenter. If this is the earth, here we have the focus, right? So focus, what happens at the focus, your energy is being released. So once this energy is released, it is reaching the surface of the earth. So the point where it reaches the surface of the earth, which is above the below the focus, right? So the point above the focus is called as your epicenter. Kunal sir, some video is in. Hi guys, sorry for the interruption. There was some technical glitch. So okay, so let's just continue with where we were. So we were at the focus and the epicenter, right? So the point which is lying on the below the Earth's surface, where your earthquake is originates, is called as your focus, right? Which we have understood. But what is an epicenter? Epicenter is the point which is just above the focus and which lies on the Earth's surface. That is called as your epicenter. Understood? So focus is where your energy is originating, or where the seismic waves originate, and once this energy is reaching the surface of the earth, that point is called as your epicenter. Understood? So the first surface point to experience the earthquake waves is the epicenter. All right, so we have understood what is a focus, and we have also understood what is an epicenter. Now let us understand what are isoseismic lines. This is very, very important. So let us define what is an isoseismic line. So it is a line connecting all the points on the surface where the intensity is the same, is called as your isoseismic line. For an example, if I consider two places, suppose I consider Delhi in your West India or your Northwest India, and suppose if I consider uh, Gangtok. Fine. Now suppose the, what is the definition? All the lines, or a line connecting all the points on the surface where the intensity is the same. Suppose the earthquake or the intensity of the earthquake in Delhi is same as that of your Gangtok, then we will connect a line between Delhi and Gangtok. And this line which is connecting places of equal intensity, these are called as your isoseismic lines. For an example, look into this diagram which is given in your right hand side. So these lines that you see here, these lines, so these are the lines which are connecting places of your equal intensity of your seismic waves. Understood? So we have understood three terminologies: focus, epicenter, isoseismic lines. Focus, where your energy is originating; Epicenter is the point on the surface of the earth where the energy first reaches, and then isoseismic lines, and these are the lines which are connecting places of equal intensity of your seismic waves, right? So this was about the introduction of your topic of earthquakes, right? So now we have to understand what are the reasons or your causes behind the formation or the generation of your earthquakes, right? So the first reason is your faulting. Now what is this faulting? We already know. Now suppose this is a layer, or this is a layer of rock, and in this rock layer, suppose there is a fracture, right? Suppose there is a fracture. This fracture which is occurring on this rock layer, these are called as your joints. And when there is movement of the rock, suppose this right hand side of the rock where the fracture is taking place, suppose this layer is moving down, or this block of rock is now moving down, and when there is movement, along joints, they are called as faults. Understood the difference between joints and faults? Joints is nothing but a crack, but in case of your joints, there will be no apparent movement of the rock. But after the formation of a crack, when there is a movement of the rock, either in the upward direction or in the downward direction, when there is an apparent movement, those joints are called as your faults. And whenever your faulting takes place, these are areas of your seismic activities. Understood? So this is very, very important because this is also given in your NCERT and has been asked in your examination. What is the difference between your joint and what is your fault? Fine. So you please note the difference. All right. Okay, next point, the immediate cause of most of the shallow earthquakes, okay, is the sudden release of stress along a fault. Okay, this means that whenever there is a movement of the rock, there will be a friction, there will be development of friction and stress, and that results in release of energy, which are nothing but your seismic waves. All right. Next point, the longer the length and wider the width of the fault. So this is the fault, right? This crack that you see here, this is the faulting line. So if the length of the fault is more and if it is also wider, then what? Then the intensity of the seismic waves will also be more. This means that length and width is directly proportional to the width to the intensity of the earthquake, right? Next point, the longest rupture is seen along your reverse faults, followed by a transform fault and then by a normal fault. Now, what are these types of fault? There is a reverse fault, there is a normal fault, there is a transform fault. Now, we have understood, or in one of the previous classes, we have talked about the different types of faults, right? All right. Now, the next reason behind your faulting is your plate tectonic activities. So slipping of a land along a fault line along convergent, divergent, and your transform boundaries are it results in your earthquakes. Now, in your previous class of plate tectonics theory, we have talked about three different types of plate movements, right? Suppose these two plates are moving towards each other. This is called as your convergence. When two plates are moving away from each other, it is called as your divergence. And when they are slipping past each other, it is called as a transform boundary, right? So in all of these cases, that is a convergent boundary, your divergent boundary, along as well as your transform boundary, in all the three cases we will see formation of earthquakes. However, one point that you have to keep in mind, that even in these three cases we are getting earthquakes, but the intensity of the earthquake will vary according to your type of plate interactions. All right. For example, at your convergent boundary, we get earthquakes of magnitude of more than 8. Okay, please remember this. This is very, very important. Then at your transform boundaries, we see earthquakes of magnitude around 8, which is here, it will be lesser than 8, right? At convergent, it is more than 8. In case of your transform boundary, it will be less than 8. And in case of your divergent boundary, it will be less than 7. Okay. So if I have to consider convergent, divergent, and transform boundary, where are we seeing the most intense earthquakes? It is your convergent boundary. But if I have to compare your plate tectonics with that of your faulting, the most of the earthquakes that we see on the earth is not because of your plate tectonics, but it is because of your faulting. This is very, very important and has been asked in your APSC exam as well. So what they can give you different options, right? Which one of the following is the major cause of your earthquakes? Option A can be your faulting, option B can be your plate tectonics, option C can be your volcanic activities, and D can be your none of these. Your correct answer there will be your faulting and not your plate tectonics, right? Excuse me. Then what is the third cause behind your volcanic activity? It is what third cause behind your volcanic eruption? It is your sorry. What is the third reason behind your earthquakes? It is your volcanic activity, right? So earthquake in volcanic regions are caused by the release of elastic strain energy, both by tectonic faults and the movement of your magma in the volcanoes, right? Such earthquakes can serve as your early warning of volcanic eruptions. This means that when your magma is flowing in the upward direction, what will happen? It will result in trembling. It will result in trembling of the earth's surface along the earth's surface as well as the crust, right? So these trembles which we see, this serves as an early warning of a volcanic eruption as well. So whenever in a volcanic region, we see earthquakes, these earthquakes gives us an indication that a volcanic eruption is going to take place. Similar example, if you have to look into real-time example, such a scenario was seen in the year of 1980 along the eruptions of your Mount St. Helens. All right. Next point, there is a clear correspondence between your geographical distribution of volcanoes and major earthquakes. So always remember that wherever there is your volcanic activities, there will also be your earthquakes. And whenever there are earthquakes, in most of the cases, it is also your volcanism will take place. So both of them are going hand in hand. For an example, if you look into the Pacific Ocean, the boundary of the Pacific Ocean, right? For example, here we have the Asia. Below Asia, we have here the Australia. Then on the right hand side above, we have the North America, right? Then here we have your South America. Fine. So between these four continents, what do we have here? We have the Pacific Ocean, right? So if you look into the boundary of the Pacific Ocean, it looks like a ring. And this ring, what do we see in this ring? We see most of the volcanoes and the earthquakes. All right. So if I have to look into the distribution of volcanoes and the earthquakes on the surface of the earth, majority of them are happening where? It is happening along the boundary of the Pacific, and this boundary hence is called as a ring of fire. Why fire? Because volcanism is taking place. Understood this? Very, very simple, right? Okay, then the last cause behind your formation of earthquakes is your human induced activities. Fine. So what are these human induced activities? It can be your mining, it can be your large scale petroleum extraction, it can be your artificial lakes. Artificial lakes are nothing but your reservoirs, and it can also be your nuclear testing. All right. So these are your human activities which can also lead to your different types of different earthquakes, right? For example, what are these activities? Mining, petroleum extraction, reservoirs, nuclear tests, etc. Now, in this case of human-induced cause behind your earthquakes, there is a very important phenomena which is called as a RIS, which is your reservoir-induced seismicity. Now, what is this? Let us go and to understand that. The pressure which is offered by a column of water in a large and a deep artificial lake, that is your reservoir, it will alter your stresses along an existing fault or a fracture. Now, look into this diagram here. Suppose this is a reservoir. Here we will have the presence of water, right? And below this water layer, what will we have here? We will have rocks, right? So this is how the structure looks like. This is a reservoir or a dam. Here we will have the storage of water, right? So in this storage area, what will happen? Loading will take place, loading and unloading of water. This means that the water level in this area will either rise, that is your loading, or it will either fall, and when it falls there will be unloading, right? So this continuous process of loading and unloading, what will happen? It will induce pressure on the surface of the dam. As a result of this, whatever fracture is present in this rock, it will enlarge it, or the stress in this fracture, the stress which are induced in this fracture will increase. Stress will increase. As a result of the increased stress, what will we see? We will see your increasing movement of rocks underneath, and which results in what? This results in your earthquakes, which are your human induced earthquakes, right? So what is the next point? Loading and unloading of the water can significantly change the stress, which is your pressure. This significant change in stress can lead to a sudden movement along the fault or fracture, resulting in an earthquake. Okay, let's continue. Okay, so where were we? We were in the topic of your loading and unloading, right? So for an example, we have understood this. Your loading and unloading will change the stress. As a result of the change in the stress, what will happen? Your movement along the fracture will take place. That is, a movement of the rock will take place, which will in turn result in your earthquake. For an example, if I have to consider a live example, for example, in the year of 1967, in your Koyna Dam or your Koyna Reservoir, which is in your Maharashtra, human induced or RIS took place. That is a reservoir induced seismicity took place, and in that incident, around 177 human lives were lost. All right. So this was about the different causes behind your earthquakes, where we talked about your plate tectonics, that is your convergent, divergent, and your transform boundary. Then we also talked about because of your volcanism, because of your faulting, and lastly because of your human induced activities. All right. Excuse me. Next, let us talk about your different types of earthquakes. Now, based on the depth of the focus, the earthquakes are classified into three different types. Okay, based on your depth of the focus. Okay, suppose this is the surface of the earth. Now, where the focus lies, or the depth of the focus from the surface of the earth, based on that, we have three different types of earthquakes. The first one is called as a shallow earthquake, where the focus is between your 0 to 70 kilometers. Then we have intermediate earthquake, where your focus is between your 70 to 300 kilometers. And then we have deep earthquakes, where your focus is between 300 to 700 kilometers. All right. So these are the three different types of earthquakes that we see. Now let us understand these three different types of focuses. First, let us talk about your shallow focus. So of the total energy which is released in the earthquake, about 12 to 15% comes from an intermediate earthquake, about 3 to 5% comes from a deeper earthquake, but around 70 to 80% of it is from your shallow earthquake. Understood this? So most of the energy which is released on the surface of the earth, which is nothing but your earthquakes, right? So most of the seismic activity is because of your shallow focus, intermediate focus, or deep focus. It is because of your shallow focus, because it constitutes around 70 to 80% of the total energy that is being released on the earth, right? It is also called as a crustal earthquake. Now, can you tell me why it is called a crustal earthquake? Because here the focus lies where? Here the focus will lie in your crustal region. Understood this? So majority of the shallow focus earthquakes are of smaller magnitudes. Okay, so it can be of the larger proportion of all the energy, it can be of the largest chunk, but in terms of magnitude, if I have to talk about, it is of your smaller magnitude, which is usually around your 1 to 5, but a few can be also of higher magnitude and can also cause a great deal of destruction. Understood this? So they occur either randomly, or they are found along your mid oceanic ridges. Now, what are mid-oceanic ridges? We have already understood this, right? So these are the areas where your ocean is originating. Fine. So your shallow focus is found where it can either occur randomly or it is found along your Morse location. All right. Next, let us talk about your deep earthquakes or your deep focus earthquakes. First point, the deeper focus earthquakes commonly occur in patterns which are called as a Benioff-Wadati zones that deep into the earth, indicating the presence of a subducting slab or a zone of subduction. This is very, very important. What is a Wadati Benioff or Wadati Benioff, or what are Benioff zones? This is very, very important. What is a Wadati Benioff? Now, suppose this is the continental crust and an ocean crust, right? This is another continent and this is another oceanic crust which is moving towards each other. All right, fine. So what happens in the next case? Because of your convergence, what will happen? Suppose this is the denser one and this will move below. We have already understood this, right? If this ocean floor, this one, your ocean floor 1, this is your ocean floor 2. Suppose your density of ocean floor 1 is more than density of ocean floor 2. So your ocean floor 1 being denser, it will subduct under your ocean floor 2, right? So we will get a we'll get a structure of this kind. This is your O1, this is your O2. O1 is subducting. This area is subducting, right? And this whole zone of subduction, this area, right, this is subducting under O2, right? So this area which is subducting under your O2, this area is called as your Wadati Benioff or Benioff zone. Fine. And this zone is related to your deep focus earthquakes. All right, understood this? Fine. Hence, they are also called as an intraplate earthquake. Why the term intraplate? Because this is happening because of a convergence of two different plates, right? See, this is what it means, triggered by collision between the plates. Okay, collision between lithospheric plate L1 and lithospheric plate L2. So, but the earthquakes alone may not cause much destruction, as the foci of the quakes lie at a great depth and the energy of the quakes dissipate over a wider area. This means that in case of your deep focus, the focus is at a greater depth, right? So by the time it reaches the surface of the earth, it has already dissipated much of its energy. As a result of this, its intensity when it reaches the surface of the earth can be of little significance. Understood this? Fine. So this was about the different types of earthquakes, right? Next, let us talk about the distribution of the earthquakes. Now, in one of the previous slides, we have said that most of the earthquakes and volcanoes, where do they occur? They occur along the ring of fire, which is the boundary of the Pacific Ocean, right? So let us look at the first point. Earth's major earthquakes occur mainly in belts coinciding with your margins of your tectonic plates. So along the margins of the tectonic plates, we will find most of the earthquakes. Fine. The most important earthquake belt is your circum-Pacific belt, which we have talked about. Circum-Pacific belt is nothing but your boundary of the Pacific Ocean, which affects many populated coastal regions around the Pacific. Like what? Like New Zealand, New Guinea, Japan, Aleutian Islands, Alaska, western coast of both your North and South America. Fine. Next point is important. The Pacific Ring of Fire accounts for 90% of the total earthquakes which is found on the earth. Okay, fine. Next point, a second belt. Okay, so this 90% cannot be absolute. It can also vary between your 80 to 90%. Fine. Then if I have to talk about the second belt, it is called as an alpine belt, which is the Himalayan and the Alps region. This area, look into this diagram, this area which I have marked here, this is the alpine belt, and the energy released in the earthquakes from this belt is around 15% of the world's total. All right, fine. Then the mid-world mountain belt, which is your alpine belt, extends parallel to the equator from the Mexico across the Atlantic Ocean, the Mediterranean Sea, from the Alpine Caucasus ranges of the Caspian to the Caspian, Himalayan mountains and your adjoining lands. Now look into this diagram very, very careful. So where is this alpine belt? This alpine belt will extend from your Mexico, which is in your Central America, right? Which is your Central America. So it will extend from your Mexico, cross the Atlantic, reach the Africa area, then it will come toward the Mediterranean Sea region, then it will go to the Caspian and the Himalayan mountain region. Okay, so this belt is the alpine belt. So first, where it occurs, the major region number 1 is the circum-Pacific belt. Then your second region is your alpine belt. Fine. Then rest smaller amounts occurs along the Arctic Ocean, Atlantic Ocean, Western Indian Ocean, and your African Rift Valley. Fine. So this was about the distribution of the earthquake. And today's last topic, and this is also very, very important, is the different earthquake zones in India. Now, if I have to talk about the zones in India, there are 4 different zones. Starts from zone 2 and ends in zone 5. Okay, it ends in zone 5. So let us first talk about your zone 2. Okay, zone 2 is falling under your low intensity zone. Okay, so as we move from 2, 3, 4 and 5, your intensity of the earthquake will increase. All right, so your zone 2, your intensity will be the least, and it covers around 40.93% of the country, and it comprises mostly of your central India, like your peninsular region as well as the Karnataka plateau area, right? Then we have the zone 3 where the intensity will slightly increase. Therefore, we will say that this area falls under the moderate intensity zone, and it covers around your 30.79% of the country. All right. So it comprises of your Kerala, Goa, Lakshadweep, then some parts of your UP, Gujarat, West Bengal, then parts of Punjab, Rajasthan, Madhya Pradesh, Bihar, Jharkhand, Chhattisgarh, Maharashtra, Odisha, Andhra Pradesh, Tamil Nadu, as well as some parts of Karnataka. All right. Next, we have your zone 4 where the intensity will increase, and this area falls under the category of your severe intensity zone, and it covers 17.49% of the country, and it comprises of some parts of Jammu and Kashmir, Himachal Pradesh, your NCR region of Delhi, then we have the Sikkim, then northern parts of UP, then Bihar, West Bengal, parts of Gujarat, smaller portions of Maharashtra, as well as your Rajasthan. All right. Then lastly, we have your zone 5. Now zone 5 is the severe intensity zone, and it covers your 10.79% of the country. Now if I have to talk about your Northeast India, the whole of the Northeast India falls under your zone 5 category. Then what are the other areas where we have zone 5? It will be in your parts of Jammu and Kashmir, Himachal Pradesh, Uttarakhand, Rann of Kutch in Gujarat, parts of North Bihar, as well as your Andaman and Nicobar Islands. All right, so this was about the different earthquake zones in India. All right, so the last topic of today's discussion is your measurement of the earthquakes. Now, how do we measure earthquakes? Now, there are 2 important scales through which we measure the earthquake. The first one is called as your Mercalli scale, and the second one is called as your Richter scale. Now, what is this Mercalli scale? This Mercalli scale represents the intensity of the earthquake by analyzing the after effects. Okay, so it basically looks into the damages which are being caused by the earthquakes, like damage to the structural integrity of a particular region. That's how we measure the intensity of the earthquake, right? And the range of intensity is from 1 to 12. All right, understood this? Then we have the Richter scale, which represents the magnitude of the earthquake. This is very, very important. Mercalli scale is measuring the intensity, while the Richter scale is measuring the magnitude of the earthquake, and it is expressed in absolute numbers from 1 to 10. 1 to 10. In Mercalli scale, what was the value? It was from 1 to 12. However, your Richter scale value is from 1 to 10. Each whole number increase in the Richter scale represents a 10 times increase in the power of an earthquake. Therefore, what can we say? We can say that the Richter scale is a logarithmic scale, and your Mercalli scale is a linear scale. Understood? So this was about the measurement of the earthquake. All right. So let us deal with 2 questions before we conclude today's class. The point where the energy is released during the earthquake, what is it called? Of course, it is called as a hypocenter, because another name of focus is a hypocenter, right? Next, the intensity of the scale of the earthquake is measured by Mercalli scale, Richter number scale, or none of the above. The answer is the Mercalli scale, because the Richter scale measures the magnitude of the earthquake, right? All right. So this is where your class ends today. In the next class, it will be a little bit more extensive, where we are going to talk about your different types of seismic waves. And this is a very large topic. Understood? So please stay tuned to Smart Coach, because tomorrow again we will come out with our live classes. And as we have already promised you, we will always be continuing with our live classes on a daily basis. All right. So thank you so much for joining us. So stay tuned to Smart Coach.